Before we move any further, let's talk a little bit more about box plot. Let's draw the box plot first and then we will explain it. Go to Task and Utilities, and then under Task, under Graphs, box plot is here, and we are going to choose, let's choose age chronic heart disease diagnosis as the analysis variable. We're not going to change anything in the appearance, we're just going to submit it. Okay, so here is the box plot. If I can draw it next to the percentiles, that will be easier to explain. Give me 1 second. It should be somewhere here. These are the results. Okay, I'm gonna put them side by side. Okay, so if we see age chronic heart disease, here is the full box plot on the left. I'm gonna make it slightly smaller. Okay, so the median value 63 is represented by the line in the center of the box. Okay, and the lower line here will be at the 25th percentile, 57. Okay, so 57 is the lower bound of the box plot, and the 75th percentile, which is 70, will be the upper bound of this box plot. Okay, and the ones which extend from the box are called the upper bound or lower bound. They simply are 1.5 times the distance between the 25th percentile, which is 57, and 70. So 70 minus 57 becomes what, 23, 13. So if we multiply 13 by 1.5, it comes down to be something like 13 times 1.5 would be 13 plus 6.5, so something like 19.5 or 20. So it will just extend 20 years below and above, and all the values which are beyond that 1.5 are considered the outliers. Okay, I created a slide to explain it in a better way. Okay, so you see the same box plot here. The diamond shape in the center is for the mean, which we already know is 63 years. And we know that most of the people are developing chronic heart disease at 63. That was the mean, and median was also very close to 63. So mean and median in this case are the same. We see that the median line is almost hugging or approximating with the mean. So that is a good thing, means that mean and median both are good representatives of the center of the age chronic heart disease variable. Now the lower bound here, we also call it first quartile or Q1. It is set at 25th percentile, as we just saw in the SAS walkthrough, which is the lower quartile or the Q1 or the 25th percentile. All of them are the same, which is 57 years, which can be interpreted that about 25% of chronic heart disease diagnosis occurred at or below 57 years of age, right? And then the upper bound, or we also call it Q3, third quartile, it is set at 75th percentile, which is 70 years. And the interpretation of the third quartile or the 75th percentile or Q3 or upper quartile is that around 75% of chronic heart disease diagnosis occurred at or below age 70. Okay, and median, as we already discussed, is 63, which means that 50% of the chronic heart disease cases were diagnosed at or before age 63. Now we talked about interquartile range, which is simply the values from the value at 75 minus the value at 25. Okay, from lower quartile Q1 to upper quartile Q3. Okay, and which is 57 to 70. That represents the central 50% of all the data values, right? Because it is from the 25th percentile to the 75th percentile. And talking about the whiskers, the lines, they extend 1.5 times interquartile range, like we as we discussed previously, which is 50, and we know that interquartile range is 13, 57, 70 minus 57 is 13, and 1.5 times of 13 would be 19.5. So if we subtract 19.5 from the lower quartile, we will draw this line, and I will tell the significance of this line. Will be set at somewhere at 37.5 years, and the upper quartile again will be the third quartile plus 1.5 times IQR or interquartile range, which comes down to be something like 89 years. Okay, so the lower bound is 37.5 and the upper bound is 89.5. So why we need to calculate the upper bound and the lower bound of these whiskers is because any value which is outside that range will be considered an outlier, and we might manually or we might like to remove those outliers. These are kind of the representation of the values which do not fall within the, I mean, these are the people who might be, I won't call them weird, but we in any data we do have some outliers for certain reasons. Sometimes there are values which are the artifact says these are kind of clerical errors, and then there are people who are totally off or totally different from rest of the data set or the rest of the values. In many cases we try to include them, but in some cases we try to have two types of analysis, including the outliers and excluding the outliers. But in a nutshell, it does provide us some information that how many extreme values are there in that variable. Okay, so the purpose is to understand the data in its essence before we get into a deeper analysis by applying the statistical test on them.